Here we are going to see the Thevenin equivalent circuit for the given circuit if we have only dependent source in the circuit. Here you can see we only have the dependent source available, that is current dependent voltage source. So whenever we have a dependent source only provided, it doesn't matter current source or voltage source, we are going to have V Thevenin that's going to be equal to 0. So if only I can take this, write the node as if the circuit has only dependent sources, then VThevenin is equal to 0. Also I Norton is equal to 0. The only thing we are going to have is resistance, and the resistance here is R Thevenin is equal to R Norton, and that one we had to find out. We can find this one by adding a source. Add a source to the circuit. And after you add this source to the circuit, you can find the R equivalent by using Ohm's law, that is V divided by I. Okay, now let's see how to do that. So first, we are gonna place a source for it. You can place a current source, you can place a voltage source, but you have to think which one is good to place, like which one is optimal, which one is easy, which one makes our life easier to solve the problem. So here, here you can see this 5 ohm resistance and 1 ohm resistance are in series. So we can add these two together first. So this is gonna be 6 ohm resistance, and then I keep the dependent voltage source as it is, plus minus 2ix. And I also keep the 4 ohm resistor as it is. And instead of this 1 ohm resistance, I'm gonna add a source. Here you have to think about which source will make our life easier. If I add a current source, you can see if I add a current source, I can do a source transformation, because the current source and this resistance are going to be on parallel. So if I do the source transformation, this is going to become a voltage in series with the circuit. So that's going to make this circuit a single loop circuit. That makes everything easier. So I'm going to add a current source right here, and let's put 1 ampere for it. That makes things easier. And here the voltage across this current is going to be the exact same voltage that we are going to have across this. Whenever, like, if you are taking the current source, you have to find out the voltage. If you are taking the voltage source, you have to find out the current. So the voltage across this is going to be the exact voltage across this resistor as well, because these two are in parallel. So the voltage is going to be the same. Now I'm going to do the source transformation. If I do the source transformation, what's this going to be? I'm going to apply Ohm's law. Ohm's law says V is equal to I times R. The current going through this is 1 ampere, and the resistance is 4. So 4 times 1, that is 4 ampere current. 4 ampere voltage, because V is equal to I times R. This is current, and this resistance is going to be 4 voltage source. So that's going to be replaced with this current source. So this 4 voltage, and the resistance remains the same. We are going to have the resistance in series. So this 4 ohm resistor comes in the series, but we still need to find out the voltage. This is plus minus voltage right here, and then this is 6 ohm resistor, and here we have the dependent voltage source, plus minus 2ix, and that is it. Now, okay, if you look at our original circuit, we have current ix flowing through this. So if it's a single circuit, then the current flow through the whole circuit is going to be ix. And if I take the current to be clockwise, I can apply KVL for this loop. Let's apply the KVL and try to solve for this ix. If I apply KVL, this is going from negative to positive, so this is going to be a minus 2ix. And then here, if the current flow from here to here, then this is going to be plus minus. So by Ohm's law, this is going to be 6 times Ix, and then here this is going to be 4 times Ix, and current flowing from positive to negative in this voltage source, so this is going to be a positive voltage, and that is equal to 0. And here how many unknown variables we have? We have Ix and yeah, only one unknown variable, so we can just simplify and solve it. So this is going to be 6 minus 2, 4, 4 plus 4, 8, 8 Ix is equal to negative 4. Therefore Ix is going to be equal to negative 4 divided by 8, that's equal to negative 1 over 2, that's negative 0.5 ampere. That negative actually represents the current is flowing in the opposite direction. Our assumption is wrong. The current is flowing in the counterclockwise direction. That's all this negative represents. Now what we want to do is we want to find out the V value, the voltage, then only we can find the resistance. Okay, so to find out the voltage, what I can do is I can take this one as, like, I can look this one as, think it like you are connecting a meter across here and taking a small loop like this. And if you do that and apply KVL, let's take this one as Ix again, clockwise. You can assume any direction for the current. So if you assume this one as clockwise, then negative V, because minus to plus, negative V, then plus Ix times 4Ix, then plus to minus, that is 4, that is equal to 0. Okay, and we already found out Ix value, that's negative 0.5, so we can plug that one here. That's gonna make this one negative 2. Negative 2 plus 4, that's 2. That's equal to V. So V is equal to 2 voltage. Now we have found out the voltage. We know the current. So we can find out the resistance. Resistance is equal to V divided by I. And we took, we found out the voltage is 2 voltage, and we put the current to be 1 ampere. So divided this one by 1 ampere. So the resistance is going to be 2 ohm resistance. So what does that mean is the R Thevenin is 2 ohm resistance. So instead of having this whole circuit, if you connect this 1 ohm resistance, like we are cutting off right here when we are doing R Thevenin equivalent. So if you connect this 1 ohm resistance with another 2 ohm resistance like this, that's going to be this entire circuit. That's basically what this means. So the equivalent circuit for this entire circuit is going to be this one. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.